The morning session will be 3 sets of speakers. The first set will be actually 2 speakers. First is Allan King with CalTrans. He is leading the recycling branch within the Office of Asphalt Pavements, specializing in smoothness and in-place recycling, which for all of us is what we want. He's been with CalTrans for 11 years and has worked in construction, METS design, and most recently the Pavement program, which provides technical guidance for the 12 CalTrans districts. The other speaker is Don Matthews with Pavement Recycling Systems. He is their technical manager and chief engineer. He focuses on the development of recycled products in pavement preservation, automated machine guidance, and other intelligent construction technologies. He has been with Pavement Recycling for the last 16 years and holds registered engineering with California and Arizona. Gentlemen? It should be on. Yeah.
I guess that's forward by forward. Well, the first thing, Brian, we're kind of the keynotes, so we have an informational video on Allan and I that just shows how great we are. So I wanted to show that.
All right, can you hit the lights, please? Oh, yeah, good morning. My name is Allan King, and I'm with CalTrans headquarters with Pavement Program, Office of Asphalt Pavements. And of course, this is Don Matthews. And so we have an exciting presentation for you guys today. So we'll discuss some of the smoothness changes that we've made to the CalTrans specifications, some of the planned outcomes, and how recycling strategies are going to be affected by these smoothness specifications. Then we'll go into little details about pre-paving corrections, opportunities, and some of the next steps that CalTrans is planning on taking. So first thing that we did with our smoothness overhaul was to take a look at what we had and try to fix what issues were there. Some of the issues that we had with our specifications previously were that contractors were having difficulty meeting the target 60 and target 75 inches per mile. Oh, yeah. All right, perfect. All right, thank you. So send that to me later. Thank you. So some of the so contractors were having issues meeting those, and what ended up happening was that there was more grinding days than actual paving days on maintenance projects, which obviously is not the goal. So CalTrans and industry got together and we worked closely on overhauling the specifications, and we'll go over some of those details. Now, the new smoothness philosophy that CalTrans has is to improve smoothness with every paving project on a 1/10 of a mile basis. So depending on the type of pavement, if it's concrete or asphalt, CAR, the existing conditions, and including a wider range of acceptance. So before we had a hardline target of 60 or 75, now we're expanding those ranges. So the department will pay in full for a smooth road, and will pay a bonus for extra smooth roadways, and if the roadways aren't as smooth as we'd like, there will be a disincentive. So the revised specification rewrite effort was a collaboration between CalTrans and industry. I think you guys are probably noticing a theme here. Yesterday we started off with partnering and collaboration. Same thing today. That was the goal, was to partner between CalTrans and industry. And we wanted to agree on the fundamental improvements that were needed, agreed on the concept for how the spec should be laid out and designed and written, and how it should apply to projects. And of course, there was joint resolution of comments. There were lots of comments. I'm sure probably many of you in this room commented on the specifications and gave us feedback, and we really do appreciate that, and we took those all into account. And of course, data, lots and lots of data. So as you can see here, each one of those dots was a data point collected from different projects, showing what kind of smoothness we could expect on a project, right? So when you do, say a 1/10 overlay, you get a certain smoothness. If you do another 1/10 or 2/10 overlay, you get another more smoothness. And so each one of those we call those each overlay, we consider those an opportunity. And so we developed a trend line and came up with a formula. I'm sure some of you will notice the basic formula that we had there, formula for a line, y equals mx plus b. So in this case, our initial formula is 0.3 times MRI plus 35. And then we have a couple additional formulas that we'll discuss later. So most importantly with the specification is that it's performance-based. So most projects that have paving on it will be incentivized. So you'll get paid extra for paving smoothly on those projects. And even more importantly, the full pay has opened up to a wider scope. So before we had a hardline target of 60, that's actually opened up to 65 for a full pay and all the way up to 80 without having to do any sort of corrections. And we're also managing by the, as discussed earlier, by the 10th mile segment. So the specifications, large rewrite for sections 36, 39, and 40. I'm sure most of you in the room don't really care about 40, but I'll go over those briefly. But section 36 applies to both section 39 and 40. In section 36, we have a smoothness quality control plan. We also have semi-permanent reference points. And so that's basically a point that we put out on the project during the design phase so that CalTrans and the contractor are all starting from the same exact point so that we can overlay our profiles and we know how much the roadway has improved. And so that we can pay the contractors those incentives that they've earned. There's also verification testing of the contractors and conflict resolution written into section 36. Now with section 39, the contractor runs the IP, the inertial profiler. And so they go out there, they collect the data, and then they submit that to CalTrans. Afterwards, the state runs quality assurance on about 10% of the data collected, and there's incentives and disincentives based off the data that's collected. And for section 40, well, it's concrete. Yeah, don't worry about that. So some of the planned outcomes with this new specification is to get California to have some of the smoothest roads in the nation. That's our goal. We also want to incentivize contractors so that they pave smoother and better, and also leading to less claims. I think we can all agree on both sides of the fence that less claims, the fewer, the better. We also want to increase the lifespan of the roads, and with a smoother roadway, it's been shown that you can decrease greenhouse gas emissions by increasing mileage and helping out the environment. So some of the big changes. Got a pointer here? Cool. So some of the big changes that we have, this is target 60, so this is for CAR and new construction. With the old specification, we had a hardline target of 60, and if you went above 60, it was a mandatory correction. You had to go out there, you had to grind it, and as I'm sure you guys are aware, that can be problematic. So even if you had a 61 or a 62, you still had to go out there and fix it. And the thing is, practically speaking, if you're driving the road, you probably can't tell the difference between a 61 and a 60. So we took that into account, and we increased the ranges. So for a target 60 project now, you can go anywhere from a 55 to a 65 and still get full pay. If you get anything below a 55, you get an incentive. And if you go anywhere between 65 and 80, if you want to leave it in place, that's okay now. Just taking the disincentive. And then, of course, anything above an 80 still does require correction. So here's a slide with lots of numbers, lots of formulas. I think everybody knows how to read. I think these slides will be sent out later, so I won't go into too much detail here. But the main points I want to show is that the thresholds of 165 and 135, depending on the thickness of the AC overlay, that affects whether it's going to be a target 60 or a target 75 project. So who here has seen this type of output? All right. Good. Glad you have. She's with the CalTrans. She should know this. So, now the rest of my CalTrans people, I don't know why your hands aren't up, but it's okay. We'll talk about that later. So this is an output for ProVal, and this is a typical run. So we got 16,000 feet here, about 3 miles, showing what the smoothness of the road is. It's measured in vertical inches per longitudinal mile, and we have a threshold here set at 135 inches per mile. Now, so what a designer would do, they would take a look at that and say, all right, well, I have all these bumps going up above the threshold. What do I want to do? Now, with the specification, that would allow for a % improvement, right? If the designer does not want a % improvement, they say, hey, you know what, I want to hit a target 60 or target 75. In this case, target 75. You know, they could say, all right, I want a pre-paving correction to be done. So they can request either a full width or a partial width segment correction. Yes, I'm throwing new terminology out at you. Fortunately, Don is here to save us. He will discuss those terminology a little bit later. But the designer has the choice if they want to do a full width and partial width or just use % improvement. So if they decide not to do anything at all, that'd be okay. And so with that, I'll hand it to Don.
Just this arrow?
Yeah.
So I'm going to talk about the new specifications and how they affect ARRA's processes. So Allan alluded to it. Before the road gets overlaid, and a designer wants to improve it, they have a choice of 3 options: structural repairs, what we call full width segment corrections, and then what we call partial width segment corrections. So structural repairs, I call them dig outs. They're isolated removal areas, fatigue areas where you take a mill down, you go down deeper, maybe 4 to 6 inches, and you pave it back. So the goal on that is essentially the contractor just has to, whether they start, before they do the dig outs, they do a run. After they do the dig outs, they do another inertial profile run. And the better of the 2 numbers is used as what's known as their baseline for when they do the paving and determine their % improvement. So essentially, a contractor just needs to make the road better than it was prior to the dig outs. So the second is full width segment corrections. And what that is, and I got to tell you what the big shift is when we switch is, originally when the ARRA came out, ProVal does nothing but grinder simulations, which when I say grinder, that's the correct term, it's diamond grinders. So everybody was correcting the existing road with diamond grinders, and it was taking days and days and days. And the big shift is, hey, we need to use micromills. They're faster, they're more effective, we can get a lot cheaper. We still left the diamond grinders as an option, but almost everybody's correcting with micromills. So on a full width segment correction, essentially it's long areas that you want to go in and profile mill. You want to get the whole entire area smoother. So what it is, and I'm going to talk about this in a few minutes, it's considered a smoothness opportunity because you mill it, you can measure it, you can improve it to what you need to do so when you place that overlay, you can meet final target smoothness. And so essentially, it's the whole width. So we come in, sections that, we go in, we mill it, we can measure it. If we need to go back, we can cut it again and get whatever's needed so that the contractor with the overlay can meet the final smoothness specification. Partial width segments are, as we found is, you know what, 90% of the road is good and we can get our final smoothness. But there's some areas that just need a little attention. So what those are just 10th mile sections, they're bid by that. And a contractor has an option. They can go in, they can micromill it, they can diamond grind it wherever they need to be. It used to be we specified you had to do it in wheel pass, but when we realized we do correct in the wheel pass, spend all this money, and then the contractor would reference on the outside of the edge lines, never use that. So now the contractor decides where they want to correct it. The other is there's a lot more machine guidance being occurred. This is just, it's going to be a fact in the future. So if you're going to go ahead and pave with a 3D paver or your cold plane, there's no sense then you need to correct it. So you just put that as your plan and do it. And the other thing that we're a little forward thinking is, you know what, other things are coming in the future. Let's not limit our specs. So if you come up with a better way of doing it, but guarantee smoothness on the final surface, you can do it. And that's essentially it. It's true performance. You're provided that segment, and you got to get that final surface. You do what you think is necessary to guarantee that final surface performance. So essentially, some things that we do as a subcontractor for our customers. Sometimes we just cut a ski run. We find out where they're going to reference their paver. We go in, we cut a nice smooth run. They reference over it. They can pave it where they want to. A lot of our customers now are just insisting that we go 3D. They just found the benefits. They're getting incentivized. There's money now available for them when they pave back, whether we do a cold planing or we hook them up for a paver. The big challenge with ProVal, as I talked about, it was all diamond grinders. So one of the things that we had to do, and ARRA's talked about it several times at some of the cold planing meetings, is figuring out how to transit that, so you need to look at it in a different way for mills. But if you know how to do it, you can use ProVal, even though it's set up for diamond grinders, to build strategies for micro mills, as opposed to just cold planing the whole area. You can do those isolated correction areas. So we talked about smoothness opportunities. What is a smoothness opportunity? So one, we defined it as a single list of asphalt, just an overlay. And essentially the thought is you got a rough surface, you come through, you pave it, and you can get smoother. With each opportunity, you get smoother. So that's one opportunity. If we do another overlay, we should get it more. And that's, if your crews aren't doing that, get them to do that, because every time you get an opportunity, you should improve the surface. But the key, it's always variable depth. That was the big concept that people had. You can't just run a constant shoe and think you're going to improve it. You have to do variable depth. So if you don't want a big difference in your paving, correct it with your milling. Variable depth your mill, get that smooth, so you do a constant lift on top of it. We also define that that an opportunity is micromilling or cold planing not in the same shift. And that's a very important distinguishment. Because essentially, when we do mill and fill in the same shift, you got to come in, mill it, and you pave it right back. You have to have good variable referencing. But we did an analysis of the data, and everybody says, well, cold planing automatically improves smoothness. Well, it does if you can reference on it, if you know the numbers you need to get, if you can measure it. So it's not in the same shift. So we took the data that we had, and I'm showing you just a list of summary of the 12 of the projects, and I want you to notice, if you look at the data, so we use CIRs from our data, and you looked at the existing CIR, if you measure it, and then the single lift overlay, we were able to get about 41%. When we did cold planing and milling in the same shift, it was only about 42% improvement from the existing surface. And then again, when we just did a single HMA over an overlay, it was about 40%. So we realized and I'm not going to say that's not going to change in the future as we get more educated, but right now we're looking at, if you mill and fill in the same shift, within California it's constant. We're constantly, the mill's 300 feet behind the paver, or just right behind the sweeper, and they've got to have it overlaid because of the traffic conditions. We can't say that's two opportunities. Now, if you mill it and you leave the traffic and we can correct it and measure it, that is a full opportunity. So the way we did it, Allan kind of showed this. I'm not going to go through it, but I want you to notice that in every situation, if you have an existing road that's too high and you're not doing any paving corrections, then you can go straight to percent improvement. There's no penalty to the contractor based on the existing road. There's only a penalty to the contractor if they don't do what they're supposed to do and use best paving practices. So really, when we look about percent improvement, I'm not going to go through this. Allan talked about that equation. Those other two equations are essentially just applying it again and again, twice. We just did the mathematics for you. But then again, opportunity, single lift of asphalt, micromilling and cold planing, not in the same shift. So if we go out and profile mill, that's one opportunity. You better get that overlay down as two opportunities. Mill and fill in the same shift is a single opportunity. But even on percent improvement, you're incentivized. So if you get that target MRI and you're within, and you beat it by 90%, of that lower, you're going to get incentive. If you go higher, then you're going to disincentive. So, CIR, smoothness. We talked about this in the smoothness or CIR committee. Well, we did a bunch of data and we found, you know what, CIR, it didn't matter what the existing surface was. If it was smooth, we're going to make it a little worse. Makes sense. We're building an air voice. If it was rough, we would make it a lot better. And we found that it was all about paving. It was all about the paving. That a contractor, if they use best paving practices, should pave it back to about a 90 inches per mile. And once we put that out, we start measuring the contractors, people who aren't doing it, did training, and all of a sudden they were getting down to it. So with a 90 inches per mile, you should be able to get with a thin lift overlay, which we typically just do a 1/10 or a 1/1500, the contractor should be able to pave a 60. If you're going to correct it, don't use diamond grinders. We have proven that. There was a big argument with that, so the state sponsored a test pass, and we found with the micro mill on one side of the road, it took about 4.5 hours. We knocked it down from a 90 to a 70 and no ALRs, individual bumps, after we got done. On the exact same shift, we used a diamond grinder. They were out there 8 hours. They didn't get it nearly as corrected, and when they started, they had 3 bumps. When they were done, they had 3 bumps. Just different areas. So micro mill is how we do everything with respect to the cold recycle strategies. So if you look at that, these are some of the existing MRIs before CIR, 77, 95, 87. One job was really poor. And you can see that with the overlay, how much improvement it could be. CIR is absolutely an opportunity for smoothness. So with that, I'll turn it over to Allan.
Thank you, Don. So now, as far as the smoothness specifications affecting cold in place recycling, the MRI for the CIR surface with the old specs and now the new specs, it still needs to be under 90 inches per mile. And any ALRs that are 240 inches per mile or greater still need to be corrected. Now, some of the changes that we've made to the CIR NSSP is that, before there was a certain amount of incentive for essentially not grinding, under 1%. But we've removed that, and now we're just sticking with the smoothness specification incentives and disincentives. So for the final overlay of HMA on top of CIR, it must be a target 60, and any ALRs must be under 160 inches per mile. So CalTrans is planning on doing training to all 12 of our districts on in-place recycling. The plan is to begin in December of this year and for a couple months into the new year. And we're going to be training on the selection process, the investigation, design, construction, and other in-place recycling strategies, including CAR, FDR, and CCPR. So, we're making this a point to really give us a push to use in-place recycling strategies more. We made it a point to have a lot of CalTrans personnel here at this meeting. There's about 20 of us here. And so we're going to roll into more training and hopefully increase the use of in-place recycling strategies across the state. And with that, one of our first CCPR projects that we're planning will be on Highway 101 in District 4. It'll be going from Palo Alto to South San Francisco, and so that'll be upcoming to CMGC projects, so we're still working out the details, but hopefully that'll be coming out pretty soon. So with that, I'd like to thank you, appreciate it, and sorry we didn't have a trailer at the beginning of the show, but hopefully we'll end on a good note. Thank you, guys.
My question is for Don. I just want to understand the difference between micro mill and just the regular mill. And if you're using, in both cases, the same sort of virtual ski to get your profile, why would you have something different in one case versus the other? Or is it the same?
So you can get smoothness. The difference is texturing. So on a regular, and I'm sorry, I don't know the millimeter, but like a 5/8 inch spacing mill, you can use a ski and you can get smoothness. So smoothness is all about wavelength and that type of thing. But by using a micro mill, we don't have a problem with raveling of the surface. So it's a matter of allowing traffic to drive it. When we do a typical cold plane, we get a lot of what we call WCs, windshield claims. It's breaking off. The peaks and valleys are such that it'll break off, and we can't leave it open. That's why we're milling and filling in the same shift so often. We can't let traffic drive on it. By using the micro milling, where we go down to like a 1/4 inch spacing and a lot smaller, tighter pattern, you're able to keep traffic on it. And that's the only reason, is to allow traffic doing it versus the smooth. You can get smoothness with either mill with the same skill. It's just allowing traffic to go on it. Any other questions?